Hi and good day to you. This is Mrs. Liao recording the lesson on inverse proportion. I'm on page 4 of your chapter 1 notes. So now let us look at inverse proportion. So we have actually learned the lesson on direct proportion. So now let's take a look at inverse proportion. Well, we say that if x is inversely proportional to y, then the two quantities are related in such a way that when x increases, then what about y? When x increases, y decreases. It is the other way. What does that mean? That means when x is doubled, y will be halved. And when x is halved, y is doubled, and so on. So now let me give you real life examples of what this means. Now, for example, if I have a distance of 100 km, let me quickly draw a straight line that represents a distance of 100 km. Let us write this down, 100 km. Now let us say, for example, I'm traveling at a speed of 50 km per meters, 50 km per hour, then the time taken will be, of course, we take distance divided by speed. That will give me, yes, 2 hours. And what if I increase the speed to 100 km per hour? What do you think the time taken will be? Will it be more or less? 100 divided by 100 gives me 1 hour. When I increase the speed, my time decreases. What if I reduce the speed from 50 to 25 km per hour? Will my time increase or decrease? So I'm going to take time taken is distance divided by speed. I will have to take a longer time than 2 hours. And you can see as the speed is doubled, time is halved. When my speed is halved, my time is doubled. So in this case, I'm going to let speed be y, and I'm going to let my x be the time. So, in order to get a distance of 100, we take speed times time. So yx is equals to 100. So what does that mean? So that means y is equals to 100 over x. And we are going to look at what has been printed for us. Yes. So we have this relationship where x times y is equals to a fixed ratio k, a fixed constant k, or we can express it as y is equals to k over x. Now this is the one that we are going to use repeatedly. So if the example is still not very clear, let me go to this space here in example 3, and I'm going to look at another example. Just need this much space for example 3. So we have extra space here. Mrs. Liao is going to look at another example with you. So we are going to look at a scenario where we have 400 food vouchers. So let's say the shopping mall has 400 food vouchers to give away. And we are going to look at what is the number of vouchers to be given away each day. Now let's say I am going to limit to only X shoppers daily, and we are going to look at the number of days that the vouchers can last. Let's call it Y days to give out the whole 400 food vouchers. Okay, so let me just quickly underline this. Okay, so let's say we are going to give out daily 50 vouchers. So how many days can the 400 vouchers last? Oops, we are going to take 400 divided by 50, so it will last a total of 8 days. And what if I increase the number of shoppers that can claim the vouchers to 80? Then I'm going to take 400 divided by 80, and the vouchers can last fewer than 8, a total of 5 days. And what if I increase the number of vouchers to be given out daily to 100? Then I'll take 400 divided by 100, and then the vouchers can only last a total of 4 days. So what do we have here? If I take X times Y, it will give me a total of 400 vouchers. And similarly, like the other example I shared with you, Y is equals to 400 over X. So what have we established? We have established that when X increases from 50 to 80 to 100, my Y will decrease from 8 to 5 to 4. So that is inverse proportion. Now let us go back to the axis and we draw in our graph. So this will be the x-axis, this will be the y-axis. So we have understood that when x increases to the right, y will decrease going down. So my graph will look like this. And you may ask me, Mrs. Liao, how come the graph cannot touch the x-axis? Well, if we look at the fraction, x is the denominator. Can x be 0? No. For this fraction to be defined, x can't be 0. X cannot be equal to 0. And if we switch the position to such that y is at the denominator, then y also cannot be 0. So this graph, if I were to draw it again, will be such that it approaches the y and the x-axis but never touching the both axes. So it's a curve. So here we go, example 3. We are looking at this phrase. Given that y varies inversely as x, we can quickly translate this phrase to y is equals to k over x. This is the meaning of y varies inversely as x, and mathematically we can write this. Now, we need to find the value of k that is relevant to this example. It has been given that when y is 6, x is 5. So we are going to sub in the values. When y is 6 and x is 5, these values allow me to look for the value k. We are going to find the value k. Can be done easily with cross multiplication. K is 30. So we can establish this equation. This equation will be y is equal to 30 over x. And this is specific to this example. And when we need to find the value of y given x, we will sub this into the equation where y is equal to 30 over x. So we can say that now when x is equal to 12, y can be found. It's 30 over 12. Now looking, we have x being 5, now it has been increased to 12. Do you think the answer will be more or less than 6? Remember, this is inverse proportion. So what will y be? Yes, you are right. When x increases, y will decrease. It will be less than 6. So let's do simple cancellation. Divide by 3. Now divide by 6. We have 5, 2. So this will be 2 now. Yes, we have made the right guess, right prediction. Y is decreasing when x increases. Okay, for do it 3, you will do it. Let me go on to example 4. Example 4 has this statement. It says y varies again inversely as, this time is x squared. So how do I translate this to a mathematical statement? This will be y is equals to, yes, you guessed it right, k over x squared. K over x squared. So what is the purpose of this information? Yes, it's to find the value of k. So we are going to write when y is 8 and x is 3 over 2. This allows me to find k. So k is equals to 8 times 3 over 2. Cancellation. I can get 1, 4, k is 12. So therefore, I am having y is equals to 12 over x squared. Don't forget your square. X squared. X squared. So Mrs. Liao forget to square here. Sorry, I made a big mistake. We have to redo this part. I forgot my square. Oh no. Okay, so let's find k again. K is equals to 8 times 9 over 4. Yeah. So k has to be 18. Right, 18, not 12. This is now 18. So here we have this equation. Now let's look back at the question. Find the equation connecting x and y. This is the equation connecting x and y. It is specific to these values. Now find also the value of y when x is 3. Where x is 3, I am going to sub in my 3, not forgetting my square. Yeah, 18 over 9 is 2. So my y is 2. Done. Okay, you have to do it for a. Mrs. Liao will show you how to do 4b. Real life example, my favorite type of questions. Force, letter F, in newtons, is about the force between two particles and is inversely proportional to the square of the distance. When you read your question, don't forget or miss out any words. So we are able to establish this equation. F, because it's inverse proportion, I write my K over the square of the distance. So we have information to help me find K. When the particles are 2 meters apart, the force between them is 10 newtons. So when, are you able to decipher? When F is, of course, force, 10, and my distance is 2, I am able to find K. This time around, Mrs. Liao will not forget to square my 2. So what is K? K is 10 times 4, which is 40. Yes, 40. So am I able to form an equation connecting the two variables? Yes. So F is equals to 40 over d square. So part A, I am able to find the force, which is which letter? Yes, F. When the distance d is 5 meters apart. When d is 5, find F. K is 40, d is 5, and I need to square it. So F is 40 over 25. Do we get a fraction? Yes, we get a fraction. Can divide by 5. This will be 8 over 5, which is equals to 1.6 Newton. Don't forget your units. Okay, now we are looking for, in part B, find the distance when the force between them is 25 newtons. So we are going to know that when my F is 25, we need to find D. F is 25 is equals to 40 over d square. Now d square. So d square is equals to 40 over 25, and d square is equals to, after cancellation, we are getting divided by 5 is 8 over 5. We need our calculator to take the square root. Now you are going to remember that there is going to be plus minus sign. So square root of 8 divided by 5. What do you get? Yes, you will get 1.2623 SF. But you know that distance can be negative value, so you are going to reject the negative value. Just put NA, not applicable. And we are going to add in the units and write 3SF. Yes! Don't forget to always relate back to the word problem. Reject any value that is not applicable. We are going to do the sums in class, but I would like you to do it for a right now as homework, as well as do it 3. Do it 3. Try it and we'll discuss in class. Alright, that's the end of my lesson. Have a good day. Goodbye.